Okay, so we have here, here's the application, remember. So I can go here and add, make sure this works. We'll add cook, it adds it. Now, one thing I've done is I'm logged in right now. So I want to have like I said, a task list per user. So this is a task list for the currently logged in user. And when I log out, okay, it takes me to this page right here, so I can log in again. If I try to access that page, if I try to go back, it won't let me go there. I have to be logged in to access the task list page. Now, this is just, this isn't tied to a database or anything. I can log in as anyone I want to. There's no password. So I'll just log in here again and take me back to the page. That's just a mock-up of a login page. When you deploy it on the App Engine, as we'll see, when you go to, if you're forced to log in, it takes you to a Google, like the page you see when you log in for Gmail. And you type in your Google Gmail address and your password to access the task list. So it handles the authentication, so we don't have to fool around with storing login names and passwords. But when you're doing it on a local machine, you see how you Google login just as a login. You don't have access to the Google login API from here, unless you're deployed on the other. Okay, so we go back and there our tasks are. We can delete them and so forth. So let's go see how they're stored. Now, first thing is we can go here. When you first fire up, when you run in development mode, if you look at the stuff that's being printed out, this URL up here will go by. It'll tell you where the development console is. So it's like _AH/admin, blah, blah, blah. And so I just went to that page to see what's happening. And it shows me, among other things, I'm using the data store viewer. So what I can see is the contents of my data store. This only works in development mode. But we're not actually using, when we're in development mode, we're not using the Google Data Store. We're using it's just using a local file system to keep track of these folders. When we deploy, then it actually uses the data store. And so you can see that there are two kinds of entity modes. Okay. So there's two kinds of entities. There's a task list, and here is, I'll display it. So there's one task list down here. It has a key, so there's a unique key for this task list. I've done 2 writes on it apparently. And it has a name, Joe. So basically, when I created the entity, I wanted to be able to access this task list by name, by username, because it's the root of my representation of a task list. And you can create an entity and let the system just make up a key for you. Or you can give the name, the entity a unique name. It has to be unique for all task lists in your application. And I think what it's doing is it's using that as a hash seed to create the key. And that just means that later on, if I want to, I don't have to store the key and remember where to go access it. I just have to remember the name, which is going to be the login name, and use that to regenerate the key, and then I can find this root. So I got one of those. And then if I look at tasks, you can see I have 2 tasks that have resulted in 4 writes. I'm not exactly sure how the writes get counted, but maybe indexes involved and such. And there it just assigned a number that was used as the starting point for this key. So you see we got the task list of 2 keys. What this doesn't show is the parent relationship. I have to figure out how to tease that out. Okay? So that's what's been created as that's the current contents of my simulated data store right now. So let's go look at the code. So what we're going to look at is this Java service implementation. So this is providing the service. There's a service called, this isn't a service, this is a helper method that gets a task list. its job is to either give it a username, and I've got it hard-coded to use Joe right here. Give it a username, it goes and creates a key, and I'm giving it a task list. That's the kind of entity I want a key for. And then Joe is the name of the key. And every time I do that, it'll give me back the same key, which is important. So I create the key, and then I come down here, data store. You see I initialize data store up there in the constructor. So that's how I get a reference to the data store up there. I come down here, I say get the entity by that key and return it. So that's just a lookup on the data store. If that succeeds, that's great, it gets returned. Otherwise, if I get an exception because there is no entity, I create a task list. So I just say create a new entity. That's the kind of entity to create, and this is the name of the entity that's, again, used to create the key. But I was mistaken when I said I had a properly called name. It's just the name is being used here. So I create the entity and put it into the data store and then return it. So one way or the other, I get the entity either looked up and returned or created, put into the database and returned. But I'm all done. I've got a root entity that I can access later because I know its name. So that's just a helper method to get a root entity. Okay, here's my first service. This is the one whose job it is. It's called by the client every time it needs a list of all the tasks in the task list. And so I do a transaction. So you can see up here, I go to the data store, I begin a transaction, down here I commit it. And if there's a problem, I roll it back. And then in between, I call get task list, which goes off into the data store and returns the root task list for Joe, because that's what's hard-coded into this. And then I write a query, because what I want to get is all the tasks out. So I create a query. Any query can only apply to one kind of entity. So I'm basically saying find tasks. Now, if that's all I put, if I said new query task, then it would find me every task in the system, regardless of what entity group they were in. It would just give me that every task in the system. But with this extra parameter right here, I'm saying limit yourself to the tasks in that entity group. So task list, remember, is my top-level root thing. I get its key and pass that set parameter query. So now it's just going to give me the tasks for that task list. So this query is operating on a give task list. Now, if I did this without qualifying it, I have a mistake. What if I just said, new query and task would return every task in the system? What would be the problem? I told you. What's that? Well, we have when I say every one in the system, I mean every one in the system that we created there, that my application created. What was the limit on transactions?
That would be the same entity group.
Right. That would be, if I did not qualify it by entity group, it couldn't be a transaction because it's going to cross entity group boundaries. So it wouldn't be able to do that in a transaction. So then I just run my query, and I get back an iterable object, which I store here. And then I iterate through it and take the stuff that I'm getting. For each task, I put something in my list and return the list. So let's see. What I'm doing is, well, I'm returning a list called tasks. Right? That's what I'm going to return. And I have an object I created called task. This is a Java thing, just a regular Java object called task. And it takes, as its parameters, the string form of the key. Okay? So my task class has a constructor, specific. It takes two parameters. One is a key, the unique key that identifies the task object in the database, the task entity in the database that this came from. And the other is the value of the task property of that entity. So this is where I'm going into the entity that I just pulled out, and I'm getting out the value of the task property, which would be mode yard, cook dinner, or whatever. And then I'm creating a task object and add that to the list. And that's what this returns to my client. So my client will go through this list and use it for corrections display. So what we've seen here is creating an entity, task list, and writing a simple query, very simple query, iterating through the results, and building a list of results to send back. So it's a bit different than a relational database. Now, we can make the queries more interesting. In addition to saying new query, in addition to telling you what to query over, what kind of things to get, and what entity group to look at, we could add filters, which basically said, you could say something like, give me all the tasks from this entity group where the name property is in the first half of the alphabet. So you can put basically selects is what it must do. They're called filters on the properties. And then you can also, after you found all the properties, you can ask it to order it in some fashion. That's all the queries, that's what queries look like. Okay, so that's the service that gets me back the tasks. Any questions I could answer about that? There's a lot of details to absorb here, but fundamentally it's very simple. Yeah.
So the data storage is active in the database in this case?
Yeah, the data store, we're not using an SQL database, we're just using Google Data Store. All right, let's look at add task. So this is when someone has typed in no yard or something and clicked add, and I'm going to add it to the task list. So all we're doing is starting a transaction, we're getting the task list, again for our default user Joe. We're creating a new entity. We're creating a task entity, and what's that second parameter? So I say new entity, kind is task. Task list.getKey. What's that task list.getKey? Right, that's my parent. So if I didn't supply that, this would be a new root entity, but I wanted to have a parent. This parent is the task list to which it belongs. Then I've got a new entity, T. I set a property. So it has a task property, which is the actual task, mow yard, what have you. And then I do a data store.put, add it to the data store, and commit the transaction. And then I return, to confirm I did the add, I return the task to the client. I create a task object in this case. So don't be confused between the kind up there, which is task, which is just a string. This is a class I defined so I can return results to the client. So I return the key of an actual task. It needs to know that key for when it does deletions. And then here is deletion. So to do a remove task, before, remember my old application, I just gave it a row to delete. And now what I do is I give it the task object to delete, and it goes in and pulls out the key, and then uses that to, the string pointing key, turns that into an actual key, and then does a delete on the data store. There's all these services. This, I keep talking about this task class right here. Okay, that's how I defined it. I just needed some way, I want to return 2 pieces of information per task to the client. The actual, the key in the data store where that task is stored, and the name, the name is really the wrong word, job or something, or activity. So I just have those 2 member variables. I have a constructor, which I use to create tasks. This has nothing to do with the data store. This is just to communicate between the server and the client. Then I have the get key to the get name. I have the set key to the set name. Now, what's going to happen if I create a list of these things? Remember, what's happening When my client says, please give me all the tasks for this task list, I send back a list of these objects. I go into the data store, pull out task entities, use them to create task objects, send them back to the client. How does the list of tasks get back to the client? How is it communicated? It's an object. We just wrote a service that says return the list to caller. Yeah, exactly. What's happening is Java needs to be able to convert objects of type task into strings, essentially, or into bytes, and send them over and have them be reconstituted. And for that to work, you've got to do two things. You've got to mark it as serializable. You've got to say this object is serializable. You're basically giving it permission to turn it into bytes. Furthermore, so it can be reconstituted on the other side. What happens on the client side when it needs to be reconstituted is it needs a zero-argument constructor to call, and it needs these setters to call. So you need to add those in to make it all work. At least I believe I have a mistake. Right now I'm standing and wondering why it wasn't necessary. But my memory is it didn't work on it now. So we're, I could be wrong. I'll try commenting those out later, see if it was necessary. So then back in the client, just for example, let's go right here. This is when we first initialized the task table and this module was loaded. So you can see we're calling get tasks. On success, we get back a list of task objects. And we basically iterate through the task objects. And first of all, we record the list as a memory variable, so we know the list of objects. And we just set the text level. So the main difference on the client side is we're communicating back task objects instead of lists. Okay, let's make a change to this. What do we need to do to pay attention to the login information? So you remember, right now this uses Joe for all. We got it set up so you can log in and log out. But it's really paying no attention